Okay, so today we're going to continue to go over the trapezoidal rule. And this time, instead of doing it like with a graph to find or estimate the area under the curve, today we're using it in order to figure out the average temperature. So remember, we estimated the area under the curve using Riemann sums, and we also did it to estimate distance. Well, this is very similar. So you can estimate distance, you can estimate the average temperature, depending on the problem. So we're going to use trapezoidal rule here, and here's how or why. So in our example, it says an observer measures the outside temperature every hour from noon until midnight, recording the temperatures in the following table. So time n would probably stand for noon because it said so in the problem. 1, 2, 3, 4, 5, so this would all be p.m. 6, 7, 8, 9, 10, 11, and then m stands for midnight, which is actually 12 a.m. And the following temperatures are in the table, 63, 65, 66. So I'm actually assuming this is going to be in degrees Fahrenheit based on the values that are given in the table. What was the average temperature for the 12-hour period? So there is a 12-hour period if you're going from noon to midnight. Noon being when t is equal to 0. And midnight is when t is equal to 12. Okay, so that's actually our A and B values. And it makes sense that we do have the same interval each time because we're going up by 1 hour. Okay, so there's a few things going on here if we're doing trapezoidal rule. So t of 12, because there are 12 subintervals. That's my approximate symbol. 1/2, because it's part of our rule, times 1, because this is actually establishing that you're going up by 1 hour each time. I'm trying to draw a number 1 here, but it's just not coming out very neatly. And then if we're using trapezoidal rule, we're going to start with 63 in our parentheses. And again, we can only use this parentheses if we know we have the same, it used to be called width, but it's, let's say, quote unquote, the height of each trapezoid, because it looks something like this. This would be the height. So we're going with 63. I'm going to erase some of this so it's neater. And then there's going to be 2 65s because there's a 65 for B2 in the first trapezoid, but a 65 for the B1 and the second trapezoid. And the same thing goes with 66 and so on. I actually don't need as many parentheses as I'm writing, and so on. 2 times 68 and 2 times 70 and so on. I'll do 2 times 62 and 2 times 58. Now, I'm over here in this last part. The 55 is the B sub 2, okay? Well, actually, it may be the smaller side. That only appears once for that last trapezoid, okay? So I'm ending it with just 155. Now, what we're evaluating here is actually just part of the question that's being asked. So when we evaluate this, it's an approximate answer of 780, okay? This is what was accumulated over the 12 hours, I could say in degrees. But my question was, what was the average temperature for the 12-hour period? So let's set up an integral that would help us find the average temperature. Now, the temperature is like a y value. The average y value would be like doing average value. So basically what this is saying here is that we need to do 1 over 12 minus 0 times the integral of f of t dt, t because we are talking about time, and we're going from 0 to 12. Okay, so what we just approximated was this integral here. And if we do 1 over 12 of our 780 degrees, we're getting approximately 65 degrees. Okay, now all our temperatures were rounded to the nearest degree, so I would keep it to the nearest degree according to the problem that's listed. So if you do get a decimal or something, that's what you would end up doing. Actually, I got 65 degrees here because this estimate was actually 782, so let's correct that. And if we did 1/12 of 782, then we get 65.1666667. It's a repeating decimal. So it comes out to 391 1/6, or 65 1/6 of a degree. But once again, because everything was rounded to the nearest degree, that's how I got my 65. Okay? So let me just make sure I correct all my 780s to 782s. Sorry, where's my eraser? There it is. Yay! Found it. All right. And that's what we're going to leave as our average temperature for the 12-hour period. All right, let me know if you have any questions, especially after that correction, but I think you should be good, so good luck.